Okay, I'm going to do videos here for, these are questions that I've gotten through email. So I just thought I would make a page that has videos of questions, and maybe everybody could benefit from them. So someone asked, this is actually part 2 of the homework, by the way, not part 3. And they asked if they were kind of having troubles, they said, with 44, 46, and 55 through 62. So we'll do something like these. I'm not going to do the exact ones, but something like them here. So 44 and 46. We have a tangent. You can see here a tangent, and then what you have here is a fraction, kind of a radian thing inside. It's a multiple angle, and this is a special angle there. Okay, all of these here are special angles. Same with this. This is sine. This is 3 pi x. That's like a special angle is equal to 1 there. Okay, so I'll start with a tangent, kind of like this. So when I say 46, this is not 46, but it's something like 46. Maybe it is tangent, we'll say pi x over 6 is equal to, let's just say, negative square root of 3. Okay, so this is how it wrote it here, which is a little strange. So let me just start off by writing it like this. Pi over 6 times x is equal to negative square root of 3, which you can do here because you just put x over 1, multiply numerator, multiply denominator. Okay, so this is a multiple angle, so what we're going to do is we're going to solve the tangent. We're going to find the angle that gives you negative square root of 3. Okay, we'll start that way. And for tangent, I'm going to, with this negative value, I'm going to get a negative angle here. So if you remember, tangent goes from like negative pi over 2 all the way up to pi over 2. And so when you have a value here and you want to know the angle, it's going to give you the angle from negative pi over 2 to pi over 2. Okay, so negative square root of 3 is actually, and I'm not going to take time to do this, but you could, it's actually going to be negative pi over 3. And you could verify that that does give you the negative square root of 3. And so now what I'm going to do is do all the if you remember, tangent is pi rotations, right? So you only need one angle for tangent. So it would be like x equal to negative pi over 3, except this isn't just x, right? It's pi over 6 times x, because that's what's inside. So this has to equal this angle plus all of kind of these multiples of pi. Okay? And so now you're going to solve for the x. So what I'm going to do, I'll just rewrite it like this. What I'm going to do is multiply both sides of my equation by the reciprocal of this radian. Like that. So now I'm going to distribute this over here. This will cancel this out. And then I get just x. And then I'm going to distribute that over. And for this one, the pi's cancel out. And I'm just left with negative 2. And then when I distribute it over here, the pi's cancel out. And I'm going to get just k times 6. So that's a weird one. When you have radians, they look a little strange, okay? But that's what it would be. So if you remember when we were graphing these, if you remember the number on the inside changed the period, and if you had a radian here, it changed the period to a whole number, right? So that's like the new period for this radian, and so these are like whole numbers here, okay, as opposed to radians. Okay, so let me do, the other one you had here was sine. So maybe what I will do is This is, you know what, this is more like 44, 46. I'll do one here. We'll say it's sine of, I'll say 2 pi x, and we'll just say is equal to negative 1/2 here instead of positive 1. And we'll solve this. Okay, so again, we're going to solve it. We're going to solve the sine of some angle here is equal to negative 1/2, and I want to get this angle, and then I'll set all of this equal to that angle. So for sine and cosine, there's two angles between 0 and 2 pi, right? And so negative 1/2, the sine of whatever angle is equal to negative 1/2. Remember, the sine is the y-coordinate, so I'm going to put negative 1/2 on the y-axis here, and one of the angles is going to be this one, and that's a special point on the unit circle, and I'm going to do the two angles between 0 and 2 pi. So this is actually 11 pi over 6. The other one is going to be over here. Okay, and so it'll go over there, and this is 7 pi over 6. So those are the two angles. So what I get is 2 pi x plus, 2 pi x is equal to, we'll say 7 pi over 6 plus k times 2 pi. And so what I do here is I divide both sides by 2 pi. Okay, so that cancels this out, and you could think of this as 2 pi over 1, and I invert and multiply over here, and you can see that I'm going to get 7, the pi's will cancel out, I'll get 7 12s, plus, and invert here, I just get k times 1, so it's just going to be k. The 2 pi cancels out, and it'll just be k. Okay, and that'll be the solution here to that. Okay, so now let's look at this. The 55 through 62. These are these problems here. And so what they are, they're multiple angles, and they involve a function that's not a special point on the unit circle. So let me do one like 56. I'll do a cosine, and then maybe I'll do like a cosecant or something. I'll do one of these other ones, okay? And then we'll stop there. So let me just do maybe something like cosine of I'll say x over 3 is equal to negative 2/5. And negative 2/5 is not a special point on the unit circle. So what I'm going to do is I'm going to have to use the inverse cosine. So I'm going to have to use my calculator and find the inverse cosine of negative 2/5. So I will do second cosine, and then I'll put in negative 2/5, and I get, this is going to be the radian that gives me that. So it's like 1.982 if I round to 3 decimal places. And so let me draw the unit circle and we can see what's going on here. So it would look like this, and negative 2/5 might be like right here somewhere. And this is on the x-axis now, because cosine is when the x-coordinate is equal to, so it's whatever angle gives you an x-coordinate on the unit circle equal to negative 2/5. And so one of them will be this point up here, and what this is saying is from here to there, this angle here is 1.982. So remember, the way cosine works is it'll give you an angle between 0 and pi. Okay, sine gives you an angle between negative pi over 2 to pi over 2. Okay, this gives you an angle between 0, cosine gives you an angle between 0 and pi. The inverse cosine. Okay, and that's what this is. Okay, this angle right here. So the other one is down here, right? And how do we get this? Well, this distance here is the same as that distance there. So what I'm going to do is I'm going to take 2 pi and I'm going to subtract 1.982. So I'm taking 2 pi, so all the way around would be 2 pi, and then I'm going to go back that distance, the same distance as that there. And let's see, I get 2 pi minus 1.982. And I get 4.301. 4.301. Okay, well, I now have these two angles, this one up here and this one here, but it's the x over 3 that's going to need to equal that. So x over 3 is equal to 1.982 plus k times 2 pi. So what I would be doing is I'd have to multiply both sides by 3, right? That gets rid of this and leaves me with just x. And so then I got to take 1.982 times 3. I get 5.946. Plus, and then I got to distribute the 3 over, so this would be k times 6 pi. So that would be one of the solutions. And then the other one involves this angle here. So I would do x over 3 is equal to 4.301 plus k times 2 pi. And then I'm multiplying both sides here by 3. And I got to distribute the 3 over, so I'm going to take 3 times 4.301. And I get 12.903. So that gets rid of this. I get 12.903. And this will be plus k times 6 pi. And that would be my other solution set. So those would be the two solution sets there. Okay, so that's one like now the other solution, I'm really going to be squeezing it in there. I'm going to try to write it over here. I get 4x is equal to 5.993 plus k times 2 pi. So now I divide both sides by 4, and I'm going to get x equal to, so I do 5.993 divided by 4, and I get 1.498 plus k times pi over 2. So these are the two solution sets to the original equation, which was the cosecant here. Okay? And so, hopefully that's helpful there. I think I'm going to just keep doing this. If people have a question, I could maybe make a video and put them up on Canvas so that everyone can benefit from the explanation.